Right then, welcome back to, let's make this, let's see what I'm doing a bit better. There we go, welcome back to part 4 of your soldering exercises, your tutorials, as it were, okay, and today we're going to be doing the dreaded SMD stuff, okay. Some of you out there think it's particularly difficult to do. I'm here to prove that it's very easy to do, okay, and it's no harder than doing through hole or large soldering, okay. So we're going to be covering, like I said, well, we're going to be soldering it using a normal solder wire, okay, thin solder here, okay, and also going to be showing you how to solder with solder paste, okay, and the components that we're dealing with are up here, okay. Yeah, so here we have it, we've got our SOICs, a couple of resistors, these are the, what value are these ones again? Pulled these ones out, these are the 0603 range of surface mount resistors, okay, 0603, we've got some SOT transistors, SOIC, so it's the usual stuff which you'll be handling for surface mount, okay. When you get your surface mount components, they normally come in strips like this, okay. We've got transistors here in this anti-static strip, we've got resistors, okay, and these cardboard sort of strip things. Okay, you just pull off the tab, get out what you need, okay. You can buy them in strips, or you can buy them by the reel. More than likely you'll get them on the strip unless you work in a factory or somewhere where you're doing some mass production. Okay, so tools that you need, okay, we've got flux, scrub block, desolder wick, cleaning brush, IPA, and most importantly tweezers. You can get away with some normal tweezers if you like, okay, or you can go out if you feel a little bit more braver, okay, you can go out and get yourself some of these are SMD tweezers, okay, all various sizes, shapes, grips, different grips. If you take a look at this one, it's designed for chips, okay, so you've got a bent, so you've got a flat tip with a sort of bent end, underneath there, I'll see it a bit better, so there we go, so you can see that a little bit clearer there, okay, all these different tips, okay, and yeah, they're all for SMD stuff, they're all used for particular devices, okay, but you can get away with normal ones, so I'm going to use these just to prove that you can. Board that we're going to be using is this little one, okay, you can see that, okay, there's something that I've been working with an external company that have been developing some circuitry and whatever, needed me to play about with it, so I've got a ton of these, so I might as well use one of these boards. Okay, moving over that way, that's the board that we're going to be working on. Okay, there you go, you can see that. I'm only going to be soldering onto the chip, tranny and the resistor. Once you get an idea of how to do it once, you know, it's pretty straightforward. One thing that you've got to be one thing that you have to do, you have to be confident in what you're doing when you're doing surface mount, because it is small, okay, well, I won't lie to you, it is a little bit more difficult than through hole, but it's not that much harder, and the key to being confident in soldering is to make sure that you're comfortable, okay, and that you've got good access to the board, and that you're going to work for it in a logical manner, so you start either from the outside and you start with the inside, work to the outside, so you're not going to disturb any components in the middle that you've soldered, or you start from one side and you work your way along to the opposite side, okay, so that way you're not going to interfere, your iron isn't going to rest on top of any other components that you need. So go from say left to right, soldering right hand side, left to right, so you go from that side to that side, okay. Other tip is prepare your board, okay. Now this board, okay, you can see it's all bare copper, okay. Soldering a surface mount to bare copper is a complete pain in the arse. if possible, get a tin your board. Okay, you can either do chemical tinning, where you can dump the entire thing into a tank. You use tin immersed powder, it's called. Okay, you can buy it in jars or in sachets. You mix it with water, not your standard tap water, clear or mineral water. Don't use that sort of stuff. Either use distillated water, deionized water, or RO water if you want. Make sure it is a purer water. Okay, it's nice and clean. Otherwise you do end up with some manky results. But yeah, it's just mix the powder with the water, and you dunk your circuit board in. This is a tinned one. Okay, it's nice and tinned. This is one that I've done myself. I was playing about with, you can see there. Okay, the entire board's tinned. Okay, you just do it with warm water, fine. But if it's one of these, okay, I really suggest that you start tinning the pads. So what you could do is scrub down the pads. If the board contains a silk like this, just scrub it all off, dunk it in your tin immerse, it comes out tinned after about a minute. If not, you don't have access to that, then grab your solder and grab your iron and dot a little bit of solder on all the pads. Okay, and then use your solder wick to wick it off. Okay, now more than likely, if you're doing this at home, you won't have access to tin immerse powder, but you can buy it off the shelf. Okay, go to, I don't know, there's a couple of places, Mega. They do it. They do it in jars or do it in little packages. Farnell, RS probably do it as well. Other places you pick up all over. It's pretty common now. So let's get started and start tinning this board and wicking it off. So I'll show you how to use solder wick, and I'll show you how to tin a PCB. Iron's on getting hot. I've got my sponge, going to wet my sponge. Got a nice wet sponge here. Like I said in the first place, it doesn't have to be saturated, just nice and damp. Okay. Clean off the tip, and we are ready to go. So, take a look at the video that's up in the corner now. What we'll do is we'll tin all the pads that we're going to be doing our surface mount on. So it's going to be that one. If your solder doesn't take to the pads, okay, it's more than likely that they're a little bit more dirty, a little bit more oxidized. So use your scrubber just to tidy up the board first before we start soldering. Okay. And what you need to do is a very small amount of solder onto each pad. You'll notice that it's a bit blobby. Okay, it's a bit bulbous when it goes on because it's sitting on the surface. But what we're going to do is we're going to wick off the excess solder. Okay, and there we have it. So it's all on there. Now, what I recommend you do, this stuff does come with impregnated with flux. Okay, but sometimes, you know, it's been sitting around for a long time. Flux has crystallised, it doesn't flow as well. It doesn't work as well as it should. So it's always useful to use your flux pen, just flux the board, add a little bit of flux to the board, and okay, you can see there, it's all flux. You can see it changing colour slightly. Okay, when the flux is sitting. Okay. Place your braid on the joint. Wick off the excess. Yeah, you're going to need to touch it on for a few seconds. And like I say, we're wicking with and your flux. Okay, comes off quite evenly. We're running the soldering iron over the top just to even it out. Okay, and we have it. Your pads are now tinned. Let's see if I can get a bit of light on that so you can actually tell the difference. Just see yourself. Well, you can see it. Okay, so it's all tinned on there. Give it a spray down with a bit of IPA, clean up the board a bit, and use a cotton bud to do this. This gets rid of all the residue, flux residue, etc. Okay, and yeah, you can see don't need to put any more light on what's actually there, you can actually see. Yeah, so we've tinned all our pads. Okay, it didn't take really 2 seconds to do. Okay, and the more you do it, the quicker it becomes. And what we need to do next is just to create a few anchor points for our components, okay? Just like a ship has an anchor to stop it moving about when it's in the ocean, or in the sea, or in docks, or anywhere like that, okay? Stops it moving about. You want to create a solder anchor point for your component, for your surface mount. So when you first attach it to the board, you solder that one pin first, okay, and it stops the chip or your component or your resistor or transistor or whatever moving about when you concentrate on doing all the other legs, okay? Saves you a pair of hands holding it on the board. So, one of the pads, just add a little touch of solder, okay, to create a little bit of solder onto the board. And then, once that's done, all you need to do is to grab your device. Let's do a resistor first. So here's a resistor, okay. So first you place it onto the pad, so the 2 pads, and you reflow that solder joint that you just did, and there it is, it's on the board, okay. One side soldered, and just to prove that you can actually pick it up, it's anchored firmly in place, okay. All that you need to do is spin the board around and dot a little bit of solder onto the opposite side. There we have it. We have a first soldered SMA component. It's that simple. Tin your pad, put an anchor on, reflow it with your component, so it's fixed in place. Just dot a solder onto the other side. Okay. We do the same thing with the transistor. I'm not too sure if this one will actually fit this box. It's the only surface mount transistor I actually had handy. Yeah, it's the right size. Yeah, standard SOT. Okay, so just reflow that first pin. It's on there. Spin it round, and just touch up the lower joints. Usually, if there's a little bit of solder left on your iron, it will flow to your pin and to your pre-tinned pad, so you don't have to actually put on that massive amount. And these are all soldered on perfectly fine. Okay, you can see no bridging or anything, no problems at all. Okay, that's how you do surface mount. Just to prove how easy it is, we will grab hold of a chip. We'll create our anchor point's up here. Okay, so we'll just orientate our board round, put the chip in place, okay, make sure that all the pins are all lined up, hold it with the tweezers, just reflow that first pin, soldered in place, there we have it. Okay, and all you need to do after that is just to dot the solder on, okay. So just go down pin by pin, and you can just dab a little bit of solder on, there we go. Simple as that. Okay, you can see that there, all soldered, all nice and even. Opposite side is still unsoldered. We'll do that now facing the camera so you can actually see that a little bit clearer. So all that you do is iron on, just run a little bit of salt. It is as simple as that. So down we go. It's a little bit more difficult doing it this way because I'm not actually facing the board. I'm not comfortable in this position, but yeah, you get the idea. Now have it. It only took a couple of seconds, and you've got a chip on the board, you've got a resistor on the board, you've got a transistor on the board. No need to flip the board over, no need to cut any cables or legacy components off. All on there, all done. It's as simple as that. So, next I've got another one that's pretty out here. This is a demo one. Okay, these components are actually glued in place. If you don't feel confident about mounting the components, you can in actual fact glue them into place. Okay, don't go mad with the glue though. You only need a very, very, very small portion, and make sure that you do not get it on your component legs. Otherwise you can end up insulating them from your copper pads, and when you solder them the solder doesn't take, or it looks like the solder's take but it's still got that insulation in there, that glue layer, and they don't take. Okay, so you can glue them in place first and then solder them up if you really want to. I don't really recommend it, and it's a pain in the arse when you have to desolder as well because they don't come off the soldering board. And if you've got tracks, especially under ICs, which do run underneath ICs, and you glue them down on top, when you pull them off you can actually tuck that track off the board as well. So be careful if you do decide to glue. Okay, some people do glue them, some people don't. It's down to your preference at the end of the day. Right, what we'll do next is we'll do the solder paste. Okay, if you do solder paste, we'll go down the chip because it's the most commonly used one for this. Okay, so first of all what we do is, because this is a reasonably old board, nothing about we'll scrub this up first with our scrub block. Okay, make it nice and shiny. You can see the difference in it already, nice and shiny. A little bit of flux on the board. I always recommend doing a little bit of flux whenever you're using surface, whenever you're using paste. Okay, and if you do get a syringe of it, make sure that you do keep it in the fridge. Okay, because it does go off quite quickly. It has got a lifespan on it. Put it in the fridge, it does last that little bit longer. I've had this stuff for about 2 years now, and it's meant to go out of date last year. It's still perfectly fine. Still does the job wonderfully because I kept it in the fridge. So here we go. So when you do a chip, you do a line of paste. Alright, we'll do another one down the opposite side. Just like that. Okay, so you've got 2 lines of solder paste. Not too much, not too little. Grab your chip. And your iron. Okay, so got our iron, got our chip. Place it on so it's, you hold it down over the solder paste on the pads like so. Okay, and all that you need to do is to run your iron down your chip like that. Okay, and it's soldered in place. That's all done on one side, and you can just do it the same thing on the other side. So you just flow it down slowly, just draw it across the legs, and there we have it. All nice and soldered in place. You can see that all the solder joints are all connected, all on that side, all joined up, except for this little end one. Okay, this one here just needs a bit of touching up done. You might want to just retouch it up with the iron. There we go, soldered in place. Okay, job's a good one. It's the beauty of solder paste. Okay, solder's on the board already, you don't need to hold up your hands, you can concentrate holding your component with the tweezers if you really want to, or keeping your board in place, stop it moving, and it's in place. And it's exactly the same thing if you've got a chip or anything. Can't really do it on that board, let's do it on this board, this tin one. Okay, I've got, let's do it between this point here. Okay, it's the board that I made myself. Okay, what you do is you dot the paste on, grab your component. I did have another resistor knocking out somewhere. There it is. There we have it. We've got our resistor here. You can just about see that. Spin the board around to make sure that it's in a comfortable position. Usually so that it's soldering across this way, and the boards you solder side to side rather than top to bottom. It makes life a hell of a lot easier. So all that you do is position your component onto the pad where the solder paste is. Make sure you've got some solder paste underneath the component, and whack the iron on. done. And then you do the same thing to the other side, and it's when you're doing little components like this, it's always best to keep your hands on them, otherwise they do go free and fly free, and there we have it. It's soldered in place. We can do that. There we are. Okay. That's how you use solder paste. Soldering onto boards like this, or boards like this. If it's copper, make sure you prep the board, tin the pads. If it's on pre-tinned, just whack it on straight away. Don't forget to do your anchors, and surface mount is really easy. Okay, there's not that much difficulty to do. Like I said, once you've finished your board, you can spray it over again with your IPA, get your brush, scrub it down. Okay, if you use a brush like this, this is an ESD one. Okay, so that's safe. Okay, and if you do use your brush, okay, what this does is it does two things actually. One, it cleans your board when you scrub it down. It gets rid of all that crap. Okay, all that flux residue and any impurities that was in the solder. It comes up with blobby brown bits all over your board. Okay. One thing, it cleans off your board. Two, okay, you can actually see whether or not the bond between the component and the joint and the solder and everything soldering is a strong joint. Because this is quite coarse, okay, and it's quite okay, just like a toothbrush. Okay, it's quite hard bristles. Okay, actually putting a lot of force onto the components. If it hadn't been soldered properly to the joint, you'd end up knocking that component off, or moving it about on the pad, and when you inspect afterwards, you'd see it is shifted, and you know whether or not that you've got to touch up that particular joint or not. And also it gets rid of all that flux and crap around your component legs and things like that. So it allows you to inspect to make sure that you have got a good joint between the component leg and your pad and your solders in there. And yeah, it's good. It's as simple as that. There's not that much difference between doing surface mount and through hole. It's the same thing. Just holding an iron in at an angle, feeding your solder, or you have your solder already on the board and feed it. You just reflow it with your soldering iron, and so on. Now, next thing, what you can do for some chips, okay, I did say that you can run your soldering iron down. Some soldering irons, okay, you can buy what are called bevel tips or well tips. Okay, I spoke to you before. You take a look at the, I think it was either the second or the first, no, possibly the second video, okay, or the first video. I spoke about solder tips. I said you get beveled ones for surface mount. Okay, they're really good because they've got a well in the actual tip. Okay, it's angled, it's got a well, and what you can do, it's like before when you apply your solder to increase your heat profile, okay, because it's got a well, it balls up the solder in the actual well. And you put solder onto the iron, it will burn off the flux, and you need to flux your board. So what you do is you flux your board, place your component on without any solder, because your solder's on the iron, and you can actually hold it in place and run the solder filled iron down the component legs. Okay, the solder that's on the iron will flow to the board because you've got the flux on the board, and you can solder smaller pitched SMD components like that. You can also do it with a chisel tip. Okay, you can build up the solder on your tip, okay, and then flow it down. It is not as controlled, okay, and you probably will find that you'll have to repeat it a couple of times going down the chip, because you can't put as much solder on there. You don't want to put a huge solder ball on it. You just want to do a slight amount just to cover the surface. Unfortunately, I can't show you that because all my tips seem to have disappeared for that particular iron. I've either got huge ones or I've got small ones. Nothing in the middle, which is more suited for surface mount, unfortunately. But even if you don't have that particular tip, you can use the chisel tip or the screwdriver tip, and you can get away with soldering up these boards perfectly fine without any problems. Okay, there are ways around it. Now, the other method is to populate your entire board. Okay, so you can solder paste your board, place your components on it, and then you can reflow it in an oven. Now, you can do this at home. If you've got a domestic oven, it goes up to 220. You can get low temperature solder, okay, that does flow around 200 degrees, okay. Now, you need to put your, so all that you do is you solder paste up all your pads, place with your tweezers onto the pads, all your components, and then pop it in the oven, okay, for about, what, 3-4 minutes, maybe 5 minutes, okay, and it will actually flow that solder, and it will do all the soldering in the oven will reflow the solder paste, okay. You can get specialised ovens for this. This is a picture of one that I've got in the, which I'll use in the lab, okay. This actually goes up to about 300 degrees, 300, 350, okay, to do all our reflowing, and these ones actually do temperature profiling as well, so you can do preheat, reflow and cool down, okay, really useful, okay. And yeah, that's it for surface mount. You don't really need to know a great deal amount about that. Okay, it's mainly down to confidence. Okay, the more you do it, the easier it becomes. Okay, it's still tricky. Even I have problems sometimes with the very, 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 very fine pitch stuff. But using that weld tip, you know, it does get around that problem. And using an oven as well. So that's about it. So that was a quick little one. 20-minute video up the top. Yeah, what more do you want? Next, we'll look at doing desoldering and some rework. Okay.